Alright, this video is going to cover arithmetic series, and just before we jump in, there's some terminology. An arithmetic series is a sum of the terms forming an arithmetic sequence, which we covered in a previous video. The sum of an arithmetic series with n terms is given by the formula shown on the screen. The one on the screen requires three things: your starting term, your last term, and your term number. There are times when you will not be given the last term. In that case, you can use the formula shown on your screen now. Alright, in this case, you only need the starting term, the common difference, and the term number. So we're going to jump in and do some questions now. So find the sum of 15 terms for each series. So because we're not given the last term here, we're going to be using our second formula. And as in a previous example video, you always should be writing down what the question gives you. In our case, we know n is going to be 15. We know our starting term is 2. And the common difference can be found by using term 2 take away term 1. So in our case, 7 take away 2. Once you've got that, we can substitute this into the equation, the formula, and get our answer. Now for that, you can just use a calculator, put it in and get your answer. Here we have another problem. Again, no last term. So as always, I suggest writing down the formula. Write it down what we know. Remember, because we have two negatives there, that is going to change into a positive, so 5 plus 2 is 7. And then we can substitute this into the formula. It's always a good idea to have your negatives in brackets. Alright, we'll move on to the next one. Evaluate each arithmetic series. So with this one, we are given the last number, but we don't have the term number for what that is. We don't know how many times we've added to get to 225, so we need to find n first. Now, if you recall, the term number can be found using this formula here. So I'm going to write down what we know. A equals 9, and we don't know. We know Tn this time is 225, and we know that the difference is going to be 17 take away 9. So we can substitute these in to find our n value. I'll draw my arrows to show you what I'm doing. I'm expanding those brackets out there. Alright, now we can simplify this down. Solve it like a regular equation. Whereas that cancels out. And then we can divide by 8. Alright, now that we've found that, we can use our regular formula, which was Sn equals n over 2, a plus l. We now know that n is 28. We remember that a was 9, and our last term was 225. So 28 is going to be 28 divided by 2 times 9 plus 225, which is 3,276. Alright, and we're going to do the same thing here. We don't know what n is, so we know that the term we know a is -2, n we don't know, Tn is 94, and d will be 6. Take away -2, which is 8. We'll expand the brackets. We'll simplify it down. And then we solve it like a regular equation. Remember, a was -2, L was 94, and n we found to be 13. So S13 is going to be 13 divided by 2 times -2 times 94, which is 598. Alright, here we have a word question. For what value of n is the sum of the arithmetic series 5 plus 9 plus 13 plus ... keeps going on, equal to 152? Alright, so I'm going to start this one a little bit different, and I'm going to write down what we know first. So we know Sn is 152, we know A is 5, we can find the difference by going 9 take away 5 is 4. We don't have the last term, so knowing that that is what we have, I'm going to be using this formula. Because we have everything there but the n, which means we can find it. Now I can substitute all these in. I'm going to multiply my 2 here over this side so I can get rid of any fractions. Like that. Now we can multiply the n on the inside. I'm actually going to simplify up this bracketed area first. So 304 equals n. 10 take away 4 is 6 plus 4n. I can change those brackets now. I can multiply these out. So I get 304 equals... I like to have the power, the highest power at the front, so we know that's 4n squared plus 6n. Now, there is a commonality. 4 and 6, there is a factor, so we can bring that out the front. Which means I can actually divide by 2. So we go back down to 152 equals 2n squared plus 3n. Let's bring this over here. And we have a quadratic. Alright, so there's two ways to solve this. You can either break it down yourself by factorizing, or you can use the quadratic formula. I'm going to use the quadratic formula. I'm not going to do the working on here because you should have a solid understanding at this point how to use that. So we know that n, I'll write the note using quadratic. we know that n equals 8 or n equals negative 9.5. Because we're not having negative term numbers, we know our answer is 8, n equals 8. Alright, so we'll do a quick recap to finish this video off. Remember, arithmetic series is just the sum of the terms forming an arithmetic sequence. There's two formula you need to know. One you can use if you're given the last term. If you're not given the last term, the more general formula is shown below, as you can see on the bottom of the screen. A personal preference is the bottom one. I think it can be applied in more areas, and if you're not told which formula to use, that is the one I would be using.